Hello. This is a video solution to a question that I posed to my class the other day, and I thought I would go through it like this for anyone else out there that's interested, but also for my students if they want to pop in and take a look at it later on. So the big ideas here that I'm trying to get across is first is really reinforcing the idea of what a reference type is. And essentially what a reference type is when you pass a reference type to a function, it's important to know that changes persist after the function is done. And that's because what you're doing is you're not passing by value, you're passing by reference. You're passing a reference to where that information is. And we'll see what I mean by that in a second. The other thing that this gets into is what's called postconditions. So this is an IB computer science course, and one of the things you have to know about are called preconditions and postconditions. Preconditions are pretty clear. It's the conditions that need to be true for the function to run, and this can be around the nature of the parameters. So for example, if you are passing an integer, a precondition could be that the integer is greater than 0. Postconditions are a little trickier, and this is kind of the first one that we'll talk about. And the postcondition here is essentially, remember, if you pass a reference type to a function, any changes to that will persist when the function's done. So you just basically want to watch if a reference type is passed, and there is a postcondition saying that the passed value cannot change, it means you can't change the parameter in the function. And with that said, let me show you some examples. So this is on my GitHub, this file. I've made an async no comment, just so that way you can see that without all the comments. So we have this function here called scale elements a. And we can see that it takes two parameters, a and b. And what we have is a simple loop that loops through b, and we're multiplying each element by a. So we're scaling that list. And then what I always do with students is I'll show them this, and I'll say, okay, well, I have this list L, and it has 4 elements with indexes 0 to 3. And there they are. And if I print it, what will I get? And the students will usually say 1, 2, 3, 4. And then I invoke this function scale elements A, and I pass it to and the list L. And then I print it again, and I'll say, okay, so what does it print the second time? And this is where students usually pause for a second, and I get unsure answers, but I usually get either 1, 2, 3, 4 or 2, 4, 6, 8. Because if we're scaling it by 2, we're going to multiply each element by 2. And if we run this, we see that I get 1, 2, 3, 4 and 2, 4, 6, 8. And so the second time, so this is printing, oh, that's totally the wrong language, printing 2, 4, 6, 8. And then I get the student that asks very rightfully, like, wait a second, but I haven't returned anything. And the reason why this changed is because a list is a reference type. So I'm passing a reference into this function. And so it's not a copy of the values that go into here. What's happening is I'm passing a reference to where L exists. So any changes to B persist after the function is done. And let me just pause and pull something up here for you. So this is a slide from a presentation I did, and I've uploaded the entire presentation. But if we look at this code here, we have A, which is a list. It's a reference type. And so when that line of code is executed, we get A, and it references 9.1. Notice the value isn't stored there in memory. It's actually a reference to where it is stored. So when I invoke do this, and I pass A into this, notice it's a reference. I have two references pointing at the same objects. So any changes that I make to B will persist when the function is done. So sure enough, when I run this line here and I change B and then the function stops and I print it, I actually get 10.1 because A has been changed as a byproduct. This is actually a really great thing, but it is an idea that we just need to be aware of. And that was the first function I asked the students to write. Now, I'm just going to comment this out. So the second function I asked them to write is I asked them to write scale elements B. And when students first read this, they read it and they say, well, it's the same thing. Well, it's not. Because notice, in this question, the specifics I said is you cannot change B. That is a postcondition that I state, that when this function is done, the pass parameter must remain unchanged. And so if you remember here, if any changes to B persist when this function is done. So here, if I want to scale this function, I want to scale all the elements by A. What I have to do is I have to make a new list. I'm going to call it C. I loop through every element of B, and then I append a new element onto C. So notice B is not being changed at all. So if the post condition of this is that B must remain unchanged, I have succeeded in that. So if I come down here to my test code, which is right here, and there's my test code, notice what I do is I have a list with 1, 2, 3, 4. I print the list, and then I invoke this scale element to L, and because this function returns something, I have a variable to store that, and then I print results. So I'm going to do one other thing. Before I print results, I'm going to print L as well. So if I save this now and give it a whirl, notice I get 1, 2, 3, 4, and that's where I print out the first time, which is, let's scroll up a bit. There we go. I'll find this, and I say, there it is. I get print 1, 2, 3, 4, that's that first one. And then I print L again after the function, and notice it's not changed. And the reason why it isn't changed is because I haven't modified the parameter B inside this function. And then I print results, which is the new scaled list. Passing by reference is really important. It takes a little bit to understand, but once you get it, it actually explains a lot of kind of behaviors that initially you might have thought of as odd. If you have any questions, please don't hesitate to reach out. Have a wonderful day.